Every year, more than 300,000 tons of snails are farmed worldwide to supply luxury restaurants, gourmet food markets, and the global cosmetics industry. That is the equivalent of over 10 billion individual snails raised in controlled environments, fed specialized diets, and processed through sophisticated industrial systems. But how do you farm an animal that moves slower than almost any other livestock on Earth? How do snail farmers manage breeding, feeding, and harvesting at a scale large enough to supply Michelin star restaurants in Paris, high-end grocery stores in New York, and beauty companies extracting snail mucin for anti-aging skincare products? And what does a modern snail processing plant actually look like when millions of these tiny creatures move through automated systems designed for quality control, sterilization, and global distribution? Welcome to AgriCraft, where we explore the most fascinating and unexpected corners of modern agriculture. Today, we are taking you inside the world of snail farming, also known as heliculture, to show you exactly how millions of snails are bred, raised, harvested, and transformed into gourmet escargot and premium cosmetic ingredients. From breeding barns in France to processing plants in Morocco, from family farms in the United States to export facilities in Poland, this is the complete journey of one of the world's most unusual and profitable forms of agriculture technology. All will be revealed in this video. Snail farming is not a new concept. Humans have been eating snails for thousands of years. Archaeological evidence shows that ancient Romans raised snails in special gardens called cochlearia, feeding them wine and herbs to enhance their flavor before cooking. In medieval Europe, snails were an important protein source, especially during Lent when meat was forbidden by the Catholic Church. Monks kept snails in monastery gardens and developed early techniques for fattening them on milk and wheat bran. But modern commercial snail farming as we know it today began in France in the 1980s. French chefs had been serving escargot for centuries, but wild snail populations could not keep up with demand from restaurants and export markets. Overharvesting led to declining wild snail numbers, and countries across Europe began implementing regulations to protect native species. This created a business opportunity. Entrepreneurs realized they could raise snails in controlled environments, producing consistent quality and meeting food safety standards that wild-caught snails could never achieve. Today, France remains a major player, but the global leader in snail production is actually Morocco, which exports more than 8,000 tons of processed snails annually. Poland, Romania, Spain, Greece, and Italy are also significant producers. In the United States, snail farming is a niche but growing industry, with farms operating in California, Washington, and New York. American farmers are drawn to heliculture because snails require relatively little space, have low environmental impact, and command premium prices. A kilogram of live snails can sell for $10 to $15 at wholesale, while processed gourmet escargot can retail for $50 to $100 per kilogram. The most commonly farmed species is Helix aspersa, also known as the garden snail or petit gris. This species is native to the Mediterranean region and is prized for its tender meat and manageable size. Another popular species is Helix pomatia, the Roman snail or Escargot de Bourgogne, which is larger and considered the finest for haute cuisine. A third species, Achatina fullica, the giant African land snail, is farmed in some tropical regions but is banned in the United States because it is an invasive species. Here is a shocking fact that most people do not know. Snails are hermaphrodites, meaning each individual has both male and female reproductive organs. However, they still need to mate with another snail to reproduce. During mating, two snails exchange sperm, and both can then lay eggs. A single snail can lay between 50 and 200 eggs multiple times per year, which means breeding populations can expand rapidly under the right conditions. This reproductive capacity is what makes commercial snail farming economically viable. Commercial snail farming begins with selecting high-quality breeding stock. Farmers source their initial snails from established breeders or certified hatcheries that guarantee disease-free, genetically strong animals. The breeding snails are kept in dedicated breeding pens or greenhouses where temperature, humidity, and food supply are carefully controlled. The ideal breeding environment for Helix aspersa is between 18 and 22 degrees Celsius, with humidity levels of 75 to 95%. Snails are extremely sensitive to temperature and moisture. If conditions are too dry, they retreat into their shells and seal themselves with a mucous membrane called an epiphragm, entering a dormant state called estivation. If conditions are too cold, they hibernate. Either way, growth stops and reproduction halts. Breeding pens are typically built with smooth walls to prevent snails from escaping, and mesh roofs to allow airflow while keeping predators out. The floor is covered with soil or a substrate mix that allows snails to burrow and lay eggs. Breeding snails are fed a diet of fresh vegetables like lettuce, cabbage, and carrots, along with calcium-rich supplements such as crushed eggshells or cuttlebone. Calcium is essential for shell development, and snails that do not get enough calcium will have weak, thin shells that crack easily. After mating, snails dig small holes in the soil and deposit their eggs. The eggs are tiny, about 3 to 5 millimeters in diameter, and look like translucent pearls. Farmers monitor the breeding pens closely and collect the eggs by gently sifting through the substrate. The eggs are transferred to incubation trays kept in climate-controlled rooms where temperature and humidity are precisely maintained. Incubation takes about 2 to 4 weeks, depending on the species and environmental conditions. When the baby snails, called hatchlings, emerge from their eggs, they are only a few millimeters long. They immediately begin eating the calcium-rich eggshells they hatched from, which provides nutrients and strengthens their developing shells. After a few days, the hatchlings are moved to nursery pens, where they are fed finely chopped greens and calcium supplements. As the snails grow, they are transferred to larger rearing pens or outdoor enclosures. Outdoor snail farming is common in regions with mild, humid climates like coastal France, northern Spain, and parts of California. Farmers use various systems, including open field farming, greenhouse farming, and mixed systems that combine both. In open field systems, snails are kept in fenced areas with netting overhead to protect them from birds and other predators. The ground is planted with edible vegetation like clover, which the snails graze on naturally. Farmers supplement this with additional feed delivered in troughs or scattered across the ground. In greenhouse systems, snails are raised in controlled environments where temperature, humidity, and light are regulated year-round. This allows for faster growth rates and multiple production cycles per year. Greenhouse farms can produce up to 3 generations of snails annually, compared to 1 or 2 generations in outdoor systems. However, greenhouse systems require more investment in infrastructure and energy for climate control. Feeding is a critical part of snail farming. Snails grow slowly compared to other livestock. It takes about 6 to 12 months for a snail to reach market size, which is typically 10 to 30 grams depending on the species. To speed up growth, farmers provide high-quality feed that includes fresh vegetables, grains, and specially formulated snail feed pellets. These pellets contain protein, calcium, vitamins, and minerals in precise ratios designed to optimize shell and tissue development. Water is also essential. Snails need constant access to moisture, so farmers install misting systems or sprinklers that keep the environment humid. In some farms, automated irrigation systems activate several times per day to maintain optimal moisture levels. One of the biggest challenges in snail farming is disease and pest management. Snails are susceptible to bacterial infections, fungal diseases, and parasites. Overcrowding increases disease risk, so farmers must carefully manage population density. Good hygiene practices, such as regular cleaning of pens and removal of dead snails, are essential. Some farmers use probiotics and natural immune boosters to improve snail health without resorting to antibiotics or chemicals. Harvesting snails is a delicate process that requires careful timing and technique. Snails are ready for harvest when they reach their target weight, and their shells have fully matured. A mature shell has a thickened lip at the opening, which indicates that the snail has stopped growing. Farmers check for this lip formation to determine harvest readiness. Harvesting usually takes place in the early morning or late evening, when temperatures are cooler and snails are more active. In small-scale operations, harvesting is done entirely by hand. Workers walk through the pens with collection bins, picking up snails one by one and placing them in crates. This is labor-intensive work, but it minimizes stress and damage to the snails. In larger operations, some mechanization is possible. Farmers use collection nets or specially designed rakes to gather snails from the ground and vegetation. However, because snails are fragile and can be easily injured, full automation of harvesting is rare. Unlike crops that can be harvested with combines or animals that can be herded, snails must be handled gently to preserve shell integrity and meat quality. After collection, snails are transported to holding areas where they undergo a purging process. Purging is essential for food safety and quality. In the wild or on farms, snails eat a wide variety of plants, some of which may be toxic or impart unpleasant flavors to the meat. To purge their digestive systems, snails are placed in clean pens and fed only neutral foods like flour, cornmeal, or specialized purging feed for several days. Some farmers fast the snails completely, allowing them to empty their digestive tracts naturally. This purging period typically lasts 3 to 7 days. During purging, snails are kept in well-ventilated containers with minimal stress. Dead or weak snails are removed daily to prevent contamination. After purging is complete, the snails are ready for transport to processing plants. They are packed into ventilated plastic crates or mesh bags and loaded onto trucks. Live snails can survive for several days without food or water, as long as they are kept cool and moist, so transportation is relatively straightforward. However, extreme temperatures must be avoided, so refrigerated transport is used in hot weather. The transformation from live snail to gourmet escargot happens at specialized processing plants that combine traditional techniques with modern food processing technology. These facilities must meet strict hygiene standards and food safety regulations because snails, like all mollusks, can harbor bacteria and pathogens if not handled properly. When snails arrive at the processing plant, they undergo an initial quality inspection. Inspectors examine the snails for shell damage, signs of disease, and overall vitality. Any snails that do not meet quality standards are rejected. The approved snails are then moved to washing stations. Washing is the first critical step. Snails are loaded into large rotating drums or conveyor belt systems, equipped with high-pressure water jets. The washing process removes dirt, mucus, and debris from the shells. Some plants use multiple washing cycles with different water temperatures to ensure thorough cleaning. The water used in the final rinse is often treated with food-grade sterilization agents to eliminate surface bacteria. After washing, the snails are ready for cooking. Industrial-scale snail processing uses large steam cookers or boiling tanks. The snails are placed in perforated baskets or mesh bags and submerged in boiling water or exposed to high-temperature steam. Cooking times vary depending on the size of the snails, but typically range from 3 to 10 minutes. This cooking step kills the snails humanely and makes the meat easier to extract from the shells. Once cooked, the snails move to the extraction stage. Workers use small forks, picks, or specialized extraction tools to pull the meat out of the shells. This is still largely a manual process because the shape and size of snail shells make automation difficult. Skilled workers can extract hundreds of snails per hour, but it remains one of the most labor-intensive parts of the operation. In some modern plants, semi-automated extraction machines use vibration and air pressure to help loosen the meat. But human workers still handle the final extraction to ensure the meat remains intact. The extracted snail meat is immediately rinsed again to remove any remaining shell fragments or viscera. The meat is then sorted by size and quality. Premium-grade snail meat is large, intact, and free of blemishes. Lower grades may include smaller pieces or slightly damaged meat, which is still perfectly safe to eat but is sold at a lower price, or used in processed products like snail pâté or canned escargot. After sorting, the meat undergoes a secondary cooking or blanching process. This step improves texture, enhances flavor, and further ensures food safety. The snails are briefly cooked in seasoned broth or butter sauce, depending on the final product. Traditional French escargot is cooked in garlic butter with parsley and white wine, while other preparations may use tomato sauce, herbs, or spices. For products destined for export or long-term storage, the cooked snail meat is frozen. Blast freezers drop the temperature to -30 degrees Celsius or lower within minutes, preserving the texture and flavor of the meat. Frozen snails can be stored for up to 2 years without significant loss of quality. For fresh products, the snails are chilled immediately and packaged within hours of processing. Quality control is constant throughout the processing stage. Samples are tested for bacterial contamination, including Salmonella and E. coli. Temperature control is monitored at every step to prevent pathogen growth. Processing plants that export to international markets must comply with HACCP protocols and obtain certifications from food safety authorities in the destination countries. Traceability systems track each batch of snails from the farm to the final package, allowing for rapid response if any quality issues arise. The shells are not discarded. After extraction, the empty shells are collected, cleaned, and sold to specialty markets. Many high-end restaurants prefer to serve escargot in the original shells for authenticity and presentation. The shells are sterilized, sorted by size, and packaged separately. Some shells are also sold to craft suppliers or used in calcium supplements for agricultural applications. Packaging snails for retail and food service requires careful attention to preservation and presentation. For frozen products, the cooked snail meat is portioned into vacuum-sealed plastic bags or plastic trays covered with protective film. Vacuum sealing removes oxygen, which prevents freezer burn and extends shelf life. Each package is labeled with product information, including the farm of origin, processing date, weight, and cooking instructions. For premium restaurant products, snails are often packaged in their shells. The cooked meat is placed back into clean shells, covered with garlic butter or other sauce, and arranged in special escargot dishes or trays. These products are then vacuum sealed or packed in modified atmosphere packaging, which replaces the oxygen in the package with inert gases like nitrogen to prevent spoilage. Canned escargot is another popular format. The cooked snails are placed in metal cans with brine or butter sauce, sealed, and then heat sterilized using retort machines. This sterilization process heats the cans to temperatures above 120 degrees Celsius, killing all bacteria and spores. Canned escargot has a shelf life of several years and does not require refrigeration, making it ideal for export and long-term storage. Automated packaging systems handle much of this work. Conveyor belts move products through filling stations, sealing machines, and labeling equipment. Modern plants can package thousands of units per hour with minimal human intervention. However, for premium products sold to high-end restaurants, hand packaging is still common to ensure perfect presentation. After packaging, products are transferred to cold storage facilities. Fresh and frozen snails require temperature control throughout the distribution chain. Storage rooms are kept at -18 degrees Celsius for frozen products and 0 to 4 degrees Celsius for fresh products. Inventory management systems track stock levels and ensure that products are shipped in the correct order to maintain freshness. Distribution begins when orders are received from wholesalers, retailers, restaurants, and export buyers. Refrigerated trucks transport the products to distribution centers, specialty food stores, and restaurants. For international shipping, snails are loaded into refrigerated containers and sent by sea or air freight. France is the largest importer of processed snails, bringing in over 4,000 tons annually from Morocco, Poland, and other producers to meet the demand of its restaurants and consumers. The United States, Japan, and Spain are also major importers. Snail mucin for cosmetics follows a different processing and distribution path. Some snail farms specialize in mucin extraction for the beauty industry. The snails are kept in clean environments and stimulated to produce mucin through gentle handling or exposure to steam. The mucin is collected, filtered, and processed into a purified ingredient used in anti-aging creams, serums, and masks. South Korea is a leader in snail mucin cosmetics, and Korean beauty brands have popularized these products worldwide. The mucin is valued for its glycoproteins, hyaluronic acid, and antioxidants, which are believed to promote skin healing and reduce wrinkles. Beyond escargot and cosmetics, snails have other commercial uses. Snail slime, or mucus, is used in pharmaceutical research for its potential antimicrobial and wound-healing properties. Some companies are developing medical dressings and topical treatments based on snail secretions. Snail shells, rich in calcium carbonate, are ground into powder and used as a calcium supplement in animal feed or as a soil amendment in organic farming. In the kitchen, escargot is incredibly versatile. The classic French preparation is escargot de Bourgogne, where snails are cooked with garlic, parsley, and butter, then served in their shells with crusty bread to soak up the sauce. In Spain, snails are simmered in spicy tomato sauce with chorizo and served as tapas. In Morocco, snails are sold as street food, cooked in a broth of herbs and spices and eaten with toothpicks. In modern American cuisine, chefs are experimenting with escargot in pasta dishes, on pizzas, and even in gourmet burgers. Nutritionally, snail meat is an excellent source of protein. A 100-gram serving of cooked snails contains about 16 grams of protein and only 1 gram of fat, making it one of the leanest meats available. Snails are also rich in iron, magnesium, selenium, and vitamin E. They are low in cholesterol and contain omega-3 fatty acids, similar to fish. For health-conscious consumers, escargot is a nutrient-dense food that fits into low-fat and high-protein diets. From an environmental perspective, snail farming is remarkably sustainable. Snails have a very low feed conversion ratio, meaning they require far less food to produce a kilogram of protein compared to cattle, pigs, or chickens. They produce minimal greenhouse gas emissions, and their waste can be composted and used as fertilizer. Snails do not require antibiotics or growth hormones, and they can be raised in small spaces, making heliculture suitable for urban farming and small-scale agriculture. In fact, some advocates consider snail farming one of the most eco-friendly forms of animal agriculture available today. From breeding pens in Europe to processing plants in Morocco, from luxury restaurants in Paris to beauty counters in Seoul, the journey of farmed snails is a story of patience, precision, and surprising profitability. What begins as a tiny egg buried in moist soil becomes a sustainable protein source and a sought-after ingredient in cosmetics, all through the careful application of agriculture technology and traditional farming knowledge. Through selective breeding, controlled cultivation, meticulous harvesting, and advanced industrial processing, millions of snails are raised and delivered to markets around the world every single year. This is the remarkable story of slow farming in a fast-paced world, where an ancient food source meets modern food safety standards, and where one of nature's slowest creatures has found a place in the global marketplace. If you found this exploration of snail farming as fascinating as we did, make sure to hit that like button. Subscribe to AgriCraft for more incredible farming documentaries, and drop a comment below telling us what unusual agricultural product or farming system you would like us to cover next. Thank you for watching, and we will see you in the next video.
The final stage of the giant African land snail farming